Hey guys, I'm Matthew Lee, and this video will be about the physics of mountain biking. The history of the bicycle began in 1493 when Leonardo da Vinci first drew the bicycle. Experts, however, still debate if da Vinci really drew it, especially since the design is almost 300 years ahead of its time. Around 200 years later, in 1817, the first bike was built. They called it the velocipede, and the riders basically ran while sitting on the bike. Later velocipedes began to incorporate pedals directly connected to the wheel, and eventually they had chains like the ones we know today, although they still appeared differently. Finally, in 1930, they decided to make the first prototype mountain bike. They incorporated fatter tires, springs, and a stronger frame. And then there's, of course, today's high-end bikes built from things like carbon fiber, air suspension, and ball bearings. The actual activity of mountain biking, however, has been around in some way, shape, or form since the bicycle was first invented. This is because in the 19th century, when the bike was first invented, few roads were paved, meaning people rode on some terrains similar to today's mountain trails. Of course, today's trails can be more challenging or have more obstacles because people are purposely putting rocks or digging out routes to be there in order to challenge riders or racers. It was not exactly biking on a mountain, but the term mountain biking can actually be more accurately described as simply off-road riding on some sort of trail. The trail is the key part here because some people will do some crazy riding on the side of a mountain, like in this picture. I really don't know what they're thinking, but this is still on some sort of trail. Rarely do we have a rider who's going to go onto a mountain without any type of trail. In the rare occasion that people do decide to ride on a mountain without a trail, it's usually someone who has amazing skills. And here I have a video of one of these people, and he's making his way up the mountain, although he's not very far up yet. And that was just the short little clip of the mountain biker. Now, moving on to the next part of this video, if you'll recall, I mentioned springs that were utilized on the first prototype mountain bike. This came in the form of suspension. Suspension is basically a part on the bike that is compressible and it absorbs impact when you ride over things like rocks or roots. The compressibility basically what it does is it's spreading a force over time. So this relates to physics in the sense of impulse. If you'll recall, impulse is F times t, or force times time. In a simple explanation, the concept of impulse and the suspension of the bike is basically in order to spread the force over a longer period of time. And the longer we spread the force, the less of an impact we'll really feel upon hitting something. In this first picture here, I'm showing the suspension at full length. So this is basically when you're riding along some type of flat road and you haven't hit anything. So basically it hasn't compressed yet. And then in this second photo, the suspension is compressed. You just hit something, so say a big rock, and then it absorbs the impact, so it compresses. And you can see the brownish gold part is smaller now. Another function of the suspension is to keep the wheel on the ground. So if we don't have suspension, oftentimes the wheel will just bounce off of obstacles and then your wheel will be in the air for a few seconds, so you lose friction. But suspension, since it can compress, it can stay in contact with the obstacle and right away after you've passed the obstacle, so you still have friction while you're doing that. Moving on to the last part of my video, I'll be talking about the simple drivetrain of a bike. So when people ride their bikes, I'm pretty sure people just normally pedal, don't really think about how the bike is working, and they just go wherever they want to go. But Miss Bull recommended me to talk about this in my video, so I looked into it a little bit. And although it seems pretty simple as we're riding, there's actually a few energy conversions in the process of pedaling. So the explanation is a little bit long, but here we go. So we start off with force 1, or F1, on the pedal, and that'll be just someone putting force down to their foot pedaling. And this transfers to a torque about axle 1, and axle 1 then transfers the torque to sprocket 1. Sprocket 1 would then produce a force F2 on the chain, which then translates into a tension force. This tension force then pulls sprocket 2 in the back, creating a torque about axle 2. This transfers through a connection between the axle and the wheel. So then there's a torque on the wheel. The wheel spins from the torque, and you have friction on the ground, propelling you forward. And that is how you move forward when you're pedaling on a bike. So I mentioned torque a few times in my explanation, and we learned about torque in physics. So T equals Fr is the equation for figuring out torque. In the diagram, I've labeled F1 and R1, so as long as we measure those two, we'd be able to find the torque that was put around axle 1, and then through a lot of other calculations, and basically only using this formula and figuring out tension, we'll be able to calculate the torque that is finally put through the wheel. Okay guys, so that was my video on the physics of mountain biking. I hope you learned something, and thanks for watching.